Welcome back. This is a video that goes with U1A7, so it's the second part about learning some exponent rules and practice with exponents. The first thing we're going to talk about is what happens when I raise something to the power of 0. So we're going to look at this two ways. The first way is similar to how your course content described it. Let's look at a problem like 3 to the power of 5 divided by 3 to the power of 5. So if we use our exponent rules, if I'm dividing powers with the same base, I subtract the exponents. So this must equal 3 to the power of 0. Okay, fine, but what is that? Well, we also know that whenever I divide something by itself, let's take the number 13. If I divide 13 by 13, it's always going to equal 1. I've got 13 objects. I'm splitting into 13 groups. Each group is one object. That's true for numbers. That's true for variables. X divided by x is also just equal to 1. And so that must also be true for powers. If I divide the same power top and bottom, I must get 1. So you notice here that 3 to the 5th divided by 3 to the 5th equals 3 to the 0, and it also has to equal 1. So this is one way to explain why anything to the power of 0 is equal to 1. Another way that I like to think about this is through a patterning approach. So let's take 2 as our base. So I'm going to evaluate 2 to the power of 5, 2 to the power of 4, and so on. So in each line on my paper, I'm just reducing the exponent by 1. So what is 2 to the power of 5? You could use your calculator. Maybe you already know in your head. 2 times 2 times 2 times 2 times 2, 32. 2 to the power of 4 is 16. 2 to the power of 3 is 8. 2 times 2 times 2. 2 squared is 4. And then 2 to the power of 1 is 2. So you might notice that each time I reduce the exponent, I'm just dividing by the base. In this case, I'm cutting in half or dividing by 2. So you kind of notice that pattern. As I reduce the exponent, I'm dividing by 2. So if I reduce the exponent one more time, I'm going to get 2 to the 0. So for that pattern to still hold, I need to divide 2 by 2, which is, of course, 1. And that's true for any base we can imagine. So we did this problem with 2 as our base. It's going to work the exact same way. Why don't we pick, I don't know, let's pick 5. So I'll just start at 5 cubed, 5 squared, 5 to the 1. 5 cubed, 5 times 5 times 5, 125. 5 squared is 25. 5 to the power of 1, of course, it's just 5. Again, you notice that each time I'm reducing the exponent, I'm dividing by the base. 25 divided by 5 is 5. So if I want to reduce the exponent one more time, 5 to the power of 0, I'm going to divide by 5. I'm going to keep my pattern, so it has to equal 1. So again, that we can see that anything raised to the power of 0 is 1. I like using this patterning approach because if I keep reducing the exponent, if I have 5 to the negative 1 or 5 to the negative 2, we can actually evaluate those negative exponents by still dividing by 5. I'm not going to put the answers to negative exponents in this video, but you're really just following that same pattern. This is actually something we cover not until grade 11 math, but you know everything about exponents and dividing and multiplying that you need to figure out negative exponents, but we're not going to cover that in this course. If you're interested, you can kind of explore that on your own, or of course send me a message and we can talk about it together. So it turns out that anything to the power of 0 is 1. So that could be a number. So I don't know, what's your favorite number? Maybe 237 to the power of 0. That's equal to 1. It could be a variable, x to the power of 0. Well, that's equal to 1. It could be any base that I have in brackets. So negative 3x cubed to the power of 0. That's still equal to 1. So anytime I raise anything to the power of 0, our answer has to be 1. One thing to be careful about is 2 to the 0 equals 1. Negative 2 in brackets to the 0 equals 1. But negative 2 to the 0 here, that equals negative 1. And again, it's just following order of operations. I'm evaluating 2 to the 0 first. I'm doing my exponents first, which is 1, and then I'm subtracting or multiplying, however you want to think about that, then it's -1. The next exponent rule that we talked about in this part of your course content is what we call power to a power. When I raise a power, so for example 2 cubed, that's a power, it has a base and an exponent. If I raise that to the fourth, I now have a power to a power. And we learned that if I want to evaluate that, I merely have to multiply the exponent. So that's going to be 2 to the 3 times 4, or 2 to the 12. And again, in this video, I'm just going to show you why that is, or what the intuition behind that is. 2 to the cubed to the fourth is really just 2 to the cubed multiplied by itself 4 times. So let's kind of expand this out. In each of these brackets, so for example, in the first bracket, I have 2 times 2 times 2. Then I multiply it by the second bracket, which is also 2 times 2 times 2. I'm going to do that 4 times. So I've got 4 groups of 3. And whenever I have multiple groups of something, I'm, of course, multiplying. So I'm multiplying 12 2's together. So that's 2 to the 12. That's kind of an explanation of our power to the power rule. So we've now learned, over the past 2 lessons, 4 exponent rules. And these exponent rules, one key thing to remember is they only work when I have the same base. So let's let A represent any base. If I'm multiplying 2 powers with the same base, so for example, A cubed times A to the 4, I'm going to add the exponents. So that'll be A to the 7. So that's the first rule that we learned in the previous content. If I'm dividing, so A to the 9 divided by A to the 5th, if I'm dividing powers that have to have the same base, so A could be any number, but they need to be the same top and bottom, then I'm going to subtract my exponents, as we talked about in the previous video, and I'm left with A to the power of 4. What we added today first is this power to a power, so A for any base. If I'm raising that to another power, I'm going to multiply my exponents. So here I'll have A to the 21. So those are our first 3 exponent rules. And then the fourth one, which we also learned, is that A to the 0, where again, A could represent any base, is equal to 1. So if we follow those 4 rules carefully, we can solve a lot of interesting problems with exponents, which is what the homework today and the quiz when you're ready will also be about. And so the idea here, they'll often ask you to simplify something to a single power and then evaluate. So I want to talk about what that means. Let's look at an example. 3 to the power of 4 times 3 to the power of 7 divided by 3 to the power of 6. So if I ask you to simplify the single power, I just want to write this with 1 base and 1 exponent. Right now I've got 3 powers. So we're just going to follow our order of operations. So I'll simplify the top. I'm multiplying powers with the same base, so I'm going to use exponent rule number 1. I'm going to add those exponents. So 3 to the 4 plus 7 is 3 to the 11 divided by 3 to the 6. And now I'm dividing powers with the same base. So I'm going to subtract the exponents, and my final answer would be 3 to the 5th. So when I say write as a single power, you would leave your answer at 3 to the 5th. If I also ask you to evaluate, that's when you could use a calculator, or that's when you're kind of multiplying 3 by itself 5 times. 3 times 3 is 9, times another 3, 27, 81, and then we have 243. So this is the answer if I ask you to evaluate. This is the answer if I ask you to write as a single power. In this example, we looked at this with a number as a base, but we can also look at problems where the base is a variable. So here's an example. This time, again, we can use our exponent rules because I have the same base. On the top, I've got a power to a power, so I'm going to multiply my exponents, x to the power of 3 times 2. And on the bottom, I'm multiplying two powers with the same base. You might ask, well, x is by itself here. What should be the exponent? Well, it's just 1x, so the exponent is just 1. I'm just multiplying, or I'm not really multiplying, I'm just writing it by itself. So on the bottom, because I'm multiplying powers with the same base, I'm going to add my exponents. So on the top, I've got x to the power of 6. On the bottom, I've got x to the power of 5. And because I'm dividing powers with the same base, I just subtract my exponents. 6 minus 5 is 1. So my final answer is x to the 1, which is probably a little cleaner and simpler just to write as x. So you're going to do a bunch of problems similar to these. You're going to be applying these exponent rules that we've learned. And then I'm going to make another video just going through some of the tougher problems on the homework. Please send me an email if you have any questions. And then when you're ready, you can try the U1A7 quiz. Okay, thanks for watching.